All right, welcome to our second exam review. So if you've not printed out, this would be a good time to print it out, and let's look at how to set each one up. All right, number one, we are given a number in base 8. We are asked to expand it and then convert it to base 10. Okay, so if we're in base 8, what this means is I've got some number to the 8 to the 0 times something times 8 to the first times something times 8 squared times something times 8 cubed. Okay, and these somethings are the digits of that number there. So that would be 3, 4, 5, and 6. And then I just want to take out a calculator and type that in. Okay, so turn your calculator on. Kind of scroll this one over. Alright, and then from here, let's see, oop, more space. Make sure I see the whole thing on the screen. Alright, so 3 times 8 cubed, and then plus 4 times 8 squared, plus 5 times 8 to the first. Now 5 times 8 to the first. 8 to the first is actually 8, so I'm just going to leave it like that instead of typing in an exponent of 1. And then 6 times 0, 8 to the 0. Now 8 to the 0, that's just 1. So in expanded form then, this number is 1,838 in base 10. And so both pieces are necessary for the answer. You need the expanded form, and you need what that actually is in base 10. Okay, in number 2, finding the number that precedes and succeeds. So find the number before and after each of the following number. One thing that I would like to use on this is just, let me just see what counting in base 7 actually looks like. So we start off with 0, 1, 2, 3, 4, 5, 6. Now I don't go to 7. Instead, I go to the next place value. So that's a 1, 0. Then it's 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. And then I go up one more place value. So 2, 0, 2, 1, 2, 2, okay, etc., etc. All right, now let's look at each position that has a 0 in it. So it's right there. And notice that the number before it has a 6 in it, and the number after it has a 1 in it. Okay, so if I want the number before 1, 2, 0 in base 7, then I want to deduct a place value, so 1, 1, and then 6 in base 7 would be the number before, and then the number after would just, where the 0 is, there's now a 1 in that position, so it'd be 1, 2, 1, base 7. Okay, number 3, convert 1,256 to base 7. So what I want to do is I'm going to set up a little, several blank spaces here. That I'm going to come in and fill in some blanks on. And I'm assuming, I don't know if it does or not, what I want to start with is the highest exponent of 7 that I can get to go into 1256. So let me get my calculator over here. Alright, so 1256 divided by, and let's see if 7 cubed goes in there. Goes in there okay, so it goes in there 3 times evenly. Let me see if I can get, well, what is 7 to the 4th? So 7, oops, clear that. Let's see if I can get the 4th power of 7 in there. Okay, so notice the 7 to the 4th is 2,401. It's already bigger than 1256. So 7 cubed looks like the biggest number I can get to go in there. Yeah, 343. Okay, so I want 1256 minus, and we said it goes in there 3 times, so 3 times the 343 gives us 227. Okay, but I already have my first digit of my expansion here. That would be the number 3. Okay, so next up is 7 squared. So how many times does 7 squared go into 227? Well, 7 squared is 49. So I can get it in there 4 times. So that number is 4. So 227 minus 4 times 49 gives me a remainder of 31. Okay, next up is 7. So how many times can I get 7 to fit in there? And that's another 4. So that blank has there's a plus there. I knew there was a plus somewhere. Alright, so there's a plus there. Alright, so let's see, we got 31 minus 4 times 7, which gives me 3. So that last one has to be a 3. So 3 times 7 to the 0th power. Okay, so anyways, in base 7, it's 3, 4, 4, 3, all in terms of base 7. Okay, a little set theory. Let's see, we're given that set A has 4 elements in it, set B has 15 elements in it, that the intersection, A or B, has 10 elements in it, and already that does not look right to me. Well, we'll see. We'll see. Then what is the intersection of that? Okay, so I've got 2 sets, set A and set B, and I know A only has 4 things in it and B has 15. Now here's sort of where I'm crying foul, so I think there's a typo on my paper that I need to go back and adjust. So hopefully when you get the printed, well, no, I already sent that out. Oh man. All right. Anyway, so we have to. Okay. So the problem here is B has 15 elements in it. So if I look at the A or B together, that has to have at least 15 in it. So that's a typo on my part. So it's got to be something bigger than 15. So we'll say 17 elements between the two of them. I'm the teacher. I can do that. And so what I want to know about then is this intersection piece. That piece right there is what I'm curious about. So the formula that connects that, so it's the number of elements in the union. I'm sorry, not in the union, but in the OR. So A or B would be the number of elements in A plus, the number of elements in A plus the number of elements in B minus the number of things that are in the intersection. Okay, so this is like a good old-fashioned equation. I've got 3 numbers, 4 blanks, so I should be able to figure out for one of my blanks, right? So we'll say 17 there, A had 14, B had 15, minus the number that I'm interested in. Okay, 14 minus 15 is 19. Okay, which means, what do I do to 19 to get 17? I happen to subtract 2 away, so that means that the number of elements in the intersection has to be 2. Okay. So sorry about that typo there. Number 5, give an example of a set that is closed under addition, then how do you know? Okay, so let me start with, give 2 examples here. Let me start with the set of numbers 0 and 1. Okay, now the reason why I know it's closed, or what is closed under addition means, well, closed under addition means if I pick any element from the set and I add it to another element from the set, I end up getting a third element that happens to be a member of the set. So in this case, if I pick 0 plus 1, I get 1, and 1 happens to be something in the set, so it is closed. Or if I switch the order, switching the order is not going to do anything for me. I still get the same thing. So if I pick any 2 elements from my made-up set, it's going to fit the closed under addition rule. Another illustration of this would be the even numbers. So 2, 4, 6, 8, ... Okay, we're just looking at the evens. So let's pick any 2 even numbers. Let's pick 2 plus 4. I get 6, and 6 is even. 2 plus 6, and I get 8. 4 plus 10, I get 14. Right? Anytime I pick any 2 even numbers, if I add them up, I'm going to generate an even number. So how do I know that I've got that it's closed? It's because if I pick, all right, so in both cases, these sets are closed because any 2 elements of the sets that I pick are in the set, or the sum of any 2 elements. Okay, let me write that out. Sets are closed because any 2 elements of the set can be added to create another member of the set. Of set. Okay. So in this type of question, what I'm looking for some sort of mathematical justification. So something that you demonstrate as you understand what the terminology is asking for. And I'm asking for the second thing would be some sort of verbal statement about what am I supposed to think about this. So what do these numbers actually tell me? They tell me that if I pick any 2 numbers and I add them up, I get something else as part of that set, which is the definition of closed under addition.